Question 4, a function given by y equal to ax squared plus bx plus c has a gradient of 9 minus half x at a stationary value of 5. Determine the values of a, b, and c in the function. So we are told that the gradient is equal to 9 minus half x, and the gradient of the function, we can always get the gradient of the function by finding dy by dx. So it means that dy by dx is equal to 9 minus half x. Let's find dy by dx. So dy by dx, differentiate with respect to x, so we multiply by the x power and subtract 1 from the x power. So the first term there, multiply by the x power, get 2ax, subtract 1 is just x to the power 1, same as x. Differentiate bx, we get bx to the power 0, which is just b. Differentiate any constant, it's 0, so 2ax plus b is equal to 9 minus half x. So now we can equate coefficients, so we can equate coefficients of the like terms. Coefficients of the like terms. So we look on the left hand side, the x coefficient, that's 2a. And we look on the right hand side, the x coefficient is negative half. Also, the constant on the left hand side, it's b. The constant on the right hand side is 9. So b is equal to 9. To solve for a here, we can simply divide both sides by 2 or multiply both sides by half. So we can multiply the left hand side by half and the right hand side by half, same as dividing by 2. So half of 2, that's 1, so 1a. And then minus 1 half times half, that's minus a quarter. So a is a quarter, b is a 9. Now we need to find the value of c. So what can we use to find the value of c now? So we are told that the stationary value at of 5, which means that if we substitute the x coordinate of the stationary value in the function, we should get 5. Let's find the x coordinate of the stationary value. So the stationary value, so function is stationary. Function is stationary when the gradient is 0. Alright, when the gradient or dy by dx is 0. And we know the gradient is 9 minus half x equals 0. So we can bring over the half x, so we end up with 9 equal to positive half x. And of course we can multiply both sides by 2. So 2 times 9, that's 18. 2 times 2, cancel 2 here, left with x. So the x coordinate for the stationary value is 18. Alright, which means that f of 18 should give us the y coordinate, which we are told the y coordinate is 5. Stationary value at 5, so we assume the y coordinate is 5. So f of 18 should give us 5. Let's substitute 18 for x in this function now. So the function is ax squared plus bx plus c. We know the value of a. We know the value of a is minus a quarter. So it's minus a quarter times x squared, replacing the x with 18, so minus a quarter times 18 squared, plus b, we know the value of b is 9, and we replacing x with 18. And if we add c, the result should be 5. Alright, so let's do the calculation now. So 18 squared divide by 4. So 18 times 18, that's 324. Divide by 4. That's negative 81. Plus 9 times 18. That's 162. Plus C is equal to 5. So we can just group everything, all the constants on the right hand side. So this means that C is equal to 5. Group 5 plus 81 minus 162. So 5 plus 81 minus 162. I'm getting minus 76. So the value of C, so this is minus 5, right? So the value of C is minus 76. Let's move on. Determine the nature of the stationary point. So the nature of the stationary point, we can take a second derivative. So we know dy by dx, which is a gradient, was 9 minus half x. So let me just write right now. So dy by dx, we know is 9 minus half x. Let's find the second derivative, which is given as d2y by dx squared. Differentiate 9, or any constant, we get 0. Differentiate negative half x, we get negative half x to the power 0, which is negative half, which is less than 0. And when the second derivative is less than 0, then it's a maximum. If it's greater than 0, it's a minimum. It's equal to 0. It's an inflection point. Part B. Alright, so part B. A drone tracks the movement of an object in motion on the ground. The following movements are recorded. So, constant velocity of 4 meters per second for 5 seconds. Its velocity increases uniformly for 3 seconds or 10 meters per second. It moves at that velocity for 7 seconds. It slows uniformly until it comes to rest after 4 seconds. Sketch the graph. So obviously we're being asked to sketch here a speed time graph. So let me just label the axis here. So it's time. So let me just label this. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, velocity 1, 2, 3, 4, 5. Let's do our sketch now. So, constant velocity of 4 meters per second for 5 seconds. So, constant velocity of 4 meters per second for 5 seconds. Alright, so 4 meters per second for 5 seconds. Here's the speed axis. 4. And it should be a straight line. Of course, I'm using freehand. Alright, we should use a ruler and a pencil. So 4 meters per second constantly for 5 seconds. So that's the first section of the graph. Then its velocity increases uniformly for 3 seconds to 10 meters per second. So for 3 seconds to 10 meters per second, alright? So for 3 seconds, another 3 seconds to 10 meters per second. So the 5th second, so it go to now to the 8th second. So 8, so it's freehand, of course, ruler. Another 3 seconds would take me to 8 seconds, right? And the speed uniformly increases, so it should be rising up to 10. Of course, I should do a ruler for that. Next, we are told that it moves at that velocity, that's 10 meters per second, for another 7 seconds. So another 7 seconds. So it's it's at now 8 seconds, and the 7 will take me to 15 seconds, right? At this velocity of 10. Alright, and the final part of the graph, it slows uniformly until it comes to rest after 4 seconds of motor space. So 4 more seconds will take me to 19. So I should have used a smaller scale, but anyway, so it will take me to 19. Oh no, I'm using that, I show you. Take me to 19, I should use a smaller scale, right? So 19 seconds it should take me to. 15, 4 more seconds, it slows. So of course, should use a ruler. Oh my, this is very untidy. So you should have a ruler to connect from here to 4 seconds later, which would take me to 19, right? So it should be a straight line. Anyway, let's see what they were asked to do now. Calculate distance traveled by the object in the second part of the journey. So area under the speed time graph gives us distance. Alright, so the second part of the journey would be this part. This is the second part of the journey, where it increases uniformly from 4 meters per second to 10. So if you look at this graph here, actually it's a what is it now? It's a trapezium, and we can break the trapezium into a rectangle and a triangle. So the rectangle, 5 to 8, so the base here is 3, length here is 3, the height here is 4. So this is 3, 5 to 8, that's 3, so 3 times 4, that's 12 square units. And for the triangular part, the area of a triangle is half base times height, right? So this is 3 times 4, right? Half base times height. The base is 3, and the height is from 4 to 8. From 4 to 10, the height is 6. So half, this is half, times the base, which is 3, times the height, which is 6. Half of 6, 2, that's 2 times. So this is half of 3 and 9. So that's 9. So the second part of the journey, the area under the graph, that's 9 and 12. So the distance traveled in the second part of the journey would be 21 meters. Alright? So area under the graph, 21. And it's got about distance, that's meters. What else are we asked to do? The acceleration in the final part. So now acceleration is change in speed over the change in time, right? So the change in speed in the final part, now the final part of the journey. The final part of the journey would be here. The speed would have been 10, original speed is 10, and the final speed would have been 0. So it went from 10 to 0. Alright, so from 10 to 0 as the question told us here. Alright, 10 to 0. And that happened in 4 seconds. Alright, so the final part of the journey. Zero, that's the final speed, minus the initial speed, 10. The time it took 4 seconds. So negative 10 divided by 4, that's negative 2.5. And it's acceleration, so meters per second square. Alright, and a negative acceleration simply means it's slowing down. In other words, it's decelerating, and that's why we have a negative value. Question 5. A toy truck moving along a miniaturized racing course with an acceleration of a equal 9t squared plus 2t minus 1, where t is time. Assume that the speed of the toy truck is measured in centimeters per second. Outline an equation for the speed of the truck, of how the speed of the truck would be found using the given equation for acceleration. So speed, So if you have acceleration and you want the speed, then you'll have to integrate acceleration. So you integrate acceleration, you'll integrate A, of course, with respect to t. 1 mark for that. Find the speed of the truck at 10 seconds. So to find the speed, we need to first integrate acceleration. Let's integrate acceleration, all right? So speed is the integral of acceleration. So that's the integral. Acceleration is 9t squared plus 2t minus 1 dt with respect to t. So we're integrating, we add 1 to the t power and divide by the whatever power we get, right? So integrate this, we get 9t cubed divided by 3. Integrate that, we get 2t, this is t to the 1, so add 1 to the power, you get 2 divided by 2. Look at 1 as t to the power 0, so add 1, you get t to the power 1 over 1 plus a constant, alright? So speed, so if we simplify this, so speed, simplify, 3 into 9, that's 3t cubed, 2 cancel 2, so that's t squared minus t, I'll put a constant there. Well, we will need a constant at t equal to 10 seconds. So we assume the limits will be, hold on. So no, we assume the limits will be 10 and 0. So 10, 0, right? So we're integrating using the limits 10. So 10 seconds. So how we evaluate? We formulate 2 brackets. In one bracket, replace the t with 10. In the other bracket, replace the t with 0. Now, if you check the second bracket, replacing t with 0, the bottom limit, everything will be 0. Replace t with 10, so we have 3 times 10 cubed, so that's 3 times 10 cubed. So 3 times 10 cubed plus, replace t with 10, plus 10 squared minus 10. And if we enter that in the calculator, with the third 3090, I remember the unit for speed is centimeters per second, alright? So careful, it's not meters per second, it's actually centimeters per second. The third part, find the distance covered by the truck between 5 and 10 seconds. Express your answer to the nearest whole number. So distance, so we get distance by integrating speed. So distance, we get distance by integrating the speed between the 5th and the 10 seconds. 10 seconds. So integrating speed. Now speed, this is speed. The expression that represents speed, that's 3t cubed plus t squared minus t, that's the expression for speed, dt. Alright? So, integrate this between the 10th and the 5th seconds, integrate 3t cubed, add 1 to the power, we get 3t to the power 4 over 4, add 1 to the power, we get t cubed over 3, add 1 to the power, we get t squared over 2. So we formulate 2 brackets. In the first bracket, replace t with 10. In the second bracket, replace t with 5. So in the first bracket, we'd have 3 times 10 to the power 4 over 4 plus 10 cubed over 3 minus 10 squared over 2. In the second bracket, we'll have 3 times 5 to the power of 4, replace t with 5 this time, over 4, plus 5 to the power of 3 over 3, minus 5 square over 2, and hence we'll end up with the first bracket will work out to be 7,813, the second bracket 498, and that will give us 7,315. And remember the units, centimeters. So part B, we can just use the reverse chain rule for this. Use the reverse chain rule. So we have a linear term expression. Reverse chain rule. We have a linear expression here, raised to a power. So the reverse chain rule, we can just add 1 to the power. We get 2. Well, we get 3 when you add 1 to the power, sorry. You get 3 and divide by the power, which is 3. New power, which is 3. And then we also divide by the derivative of the bracket, which is 2 plus c. So this we actually have solution 2x plus 3 all cube upon 6 plus c. Next, integrate cos. The integral of cos is sine, right? So it's 5 sine 2x. And of course, because we're integrating, sorry, we divide by the x coefficient there, which is 2. So 5 sine 2x over 2 plus c. Next, if dy by dx equals 6x minus 10, and y equal 12 when x equals 0, find the equation. So if we have dy by dx, to get y, we simply integrate 6x minus 10. So integrate 6x, add 1 to the power, we get 6x squared over 2. Integrate 10, we get 10x plus c. So this is y equal to 3x squared minus 10x plus c. And we are told that y is 12 when x is 0. So if x is 0, all of this is 0, so it's 0 plus c. So c is 12. So therefore, the equation for y is y equal 3x squared minus 10x plus 12. So now we're at the final section of the paper. That's the statistics section. So the following stem and leaf diagram represents the scores out of 80 of students in an ADMAT exam. Write the raw data set that was used to construct the diagram above. So this is the raw data. So each number here represents, each digit represents a number. So the first one, that's 30. So 30, 33, 37. In the second row, we have 42, 44, 46, 47, 49. This third row, that's 51, 53, 53 again, 56, and then we have 60, 67, 67 again, 71, and 79. How many numbers do we have here? Let's go on. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So we have 17 numbers. So we're asked to find the median. The median is, of course, is a middle number. So if we have 17 numbers, we can find the median So 17 plus 1 divided by 2, 17 plus 1 divided by 2, that's 18 divided by 2, 9. So the median should be the 9th number. Let's check. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So the middle number should be in the 9th position. Is it? So that's 51. The median score is that's 51. Next, we're asked to find the mean. So to get the mean, add all the numbers and divide by 17, right? So remember 17 numbers. So the mean is the sum of all the numbers. So sum of all the numbers divided by n. So when we add all these numbers, we get 884, and there's 17 of them. So the mean should be 52. And the modal score, I think we have 2 mode. If you look at even the data here, the mode. So we have 53 occurring twice, and we have 67 occurring twice. So we have 2 modes, 53, and so the mode 53 and 67. Next. Given that for the data set sum of x squared is 48,999, sum of x 885, find the standard deviation of the data set using the formula. So it doesn't matter of basic substitution. Alright, so s equal to the square root sum of x squared. Now sum of x squared, that's 48. That's basic substitution. 48, 999. Sum of x, sum of x is 885. 885 over n, which is 17, over the square root of 17 minus 1, which is 16. So we can just use a calculator and do that, and we should get 13.5. If a student needs to score at least half the total marks possible to pass the exam, determine the probability of a student failing the exam, given your answer to 2 decimal places. So to pass, so remember the test was scored out of 80. So to pass, you will need to get to probability of students failing. So if you get under 40, you will fail. Let's see how many persons fail. Let's go back to the data. Here's the data. So under 40 would fail, right? So 3 persons get under 40. 30, 33, 37. So 3 persons get under 40. Alright, so the probability of failing would be 3 out of a total of 17 students. And I want the answer to 2 decimal places. I think that's 0.18. Given that a randomly selected student has passed the exam, what's the probability that the student scored out of 60? So that is a conditional probability question. So, given that a random selected student has passed the exam, so this is what we know. We know the student passed the exam. What's the probability that the student scored above 60? So we know that a student passed the exam. Let's go back to the table. Let's check how many students passed. Well, we know 3 failed the exam. We know 3 failed the exam. And it was 17 students. So we know 14 students passed the exam. So of the 14 who passed, so 3 failed, so 14 passed. 14 got above the 40. Alright, so of the 14 who passed, how many of them scored over 60? So of the 14 who passed, 4 scored out. So notice 67. So we won't count the 60 because it's above 60. So we're not counting the 60. So 67, 67, 71, 79. So of the 14 who passed, 4 scored over 60. So we know, so it's a conditional situation here. So 14 passed. So we know that it's when the pass the exam. So 14 passed and scored over 60. We know 4 scored out of 60. And again, they want the answer in 2 decimal places. So 4 divided by 14. 0.29. 0.29. Next. Based on the stem and leaf diagram, describe the distribution of the set. So distribution. Let's go back to it. Stem and leaf again. So of course, it's not evenly distributed. Alright, so obviously the data is skewed. Alright. And it could be positively or negatively skewed. So we know it's positively skewed. And the reason we say it's positively skewed is that if you look back at the stem and leaf plot, most of the numbers, most of the data are concentrated to the left hand side. So most of the data are concentrated to the lower end, the left hand side. So we say it's positively skewed. Alright, so your friend suggested that a bar graph or histogram could be used to represent the data. Advise your friend on which graph is the better option, given one reason to support your answer. And of course, it would be a bar graph. It would be a bar graph. And why? The reason is that the data is discrete. So the data is discrete. Yeah, notice in the data we don't have any decimals or anything like that. So all the scores were given as nice whole round numbers. So we have to assume it's discrete data. And for discrete data, we use bar graph. For continuous data, we use histogram. That's it.